Let's solve the example on multi-instance RAG. In multi-instance RAG means in which the resources are having of multiple instances. As we discussed in the previous video, in which multiple instances means a resource is having more than one instances, like a register. In our system we are having more than one registers. So in the multi-instance, let's see, there is a R1 resource R2. Here R2 is multi-instance. So if the RAG is given like that, in which there is a multi-instance resources are present, again they can ask the same question, check whether this RAG, this system contains the deadlock or not. So one thing is, you can do it manually. Manually means like you can check ki first of all there is a circular weight or not. There is a, like in this there is a circular weight, so this and this, there is a cycle, and there is another process, that is P3. So you can do it manually also, like P3 having no request, P3 is requesting nothing, so P3 will get successfully execute because P3 is requesting nothing. P3 needs one resource of R2, it is having one resource. When it get execute, one resource of R2 will be free. When the resource of R2 will be free, then this resource will be given to the P1. Because one resource will be free, it will be given to the P1. Then P1 will get execute. When the P1 will get execute, R1, R2 both will be free. Then P2 will get execute. Means this is a manual way of doing. But rather than manual way, again we are solving with the same method. Let's say 3 processes, P1, P2, P3 processes, and write down allocation and request. Allocation and request of R1, R2, because there is two, one is R1 and R2, request of R1 and R2. Now, first of all, P1 has allocated one resource of R1. P1 has taken R1, so just write 1. Because P1 has taken R1. P1 has taken any other? No. Check for P2. P2 has taken one resource of R2. This is a allocation kind of. Because P2 has taken R2. So P2 has taken R2. Whether P2 has taken R1? No. P2 has not taken, it is requesting. Check for P3. P3 has taken R2. P3 has taken the one resource of R2 and not for the R1. So R1 ke liye 0 and for R3 we write 1. For R2 we write 1 because P3 has taken one resource of R2. So this is a simple way of writing the allocation. Now writing the request. Ki who is requesting for which resource? Which process is requesting? P1. P1 is requesting for R2. You can clearly check P2. P1 is requesting for R2. So P1 is requesting for R2. So just write 0 on R1 because it is not requesting of R1. P2. P2 is requesting for R1. P2 is requesting for R1. So P2 is requesting for R1. So just write 0 for the R2. P3. P3 is requesting nothing. P3 is requesting nothing. So first of all, just make the table like that. Now check the current availability. Check the current availability. What is the current availability? Means how many resources I am available. R1? No. Only one instance of R1 I have, but that is already taken by P1. Two instance of R2, but that is already taken by P3 and P2. So there is 0, 0 availability. I am having no availability. R1 is not available, R2 is not available. Now, using this availability, can I fulfill the request of any of the resource, any of the process? Yes, I can fulfill the request of P3 because P3 is demanding nothing. So when the P3 will get successfully execute, because P3 is demanding nothing, so first of all P3 will get terminated. When the P3 will get terminated, whatever the resources it is having, it is assigned, they will be free. कौन से resource है? 0 of R1, 1 of R2. So just add in the previous availability, just add it. So it will be 0, 1. So this is the new current availability. This is the new availability. 0, 1. 0 of R1, 1 of R2. Now check. Can I fulfill the request of P1 or P2? Yes, I can fulfill the request of P1 because P1 needs one resource of R2 to get execute. P1 is having R1, but it needs one resource of R2 to get execute. And yes, I am having one. So I will give this one resource to P1 and P1 will get execute. And when P1 will get execute, it will terminate. So when the P1 will terminate, whatever the resources it is having, they will be freed. So 1, 0 will be free. So just add into the previous availability. So it will be 0 plus 1, 1, 1 plus 0, 1. So what is the current availability I am having? 1, 1. Means 1 of R1, 1 of R2. So can I fulfill the request of? I am having only P2 because others are terminated. So P2, what is the request? P2 needs one resource of R1 to get execute. Do I have? Yes. I am having one resource of R1. So I simply give it to the P2 and P2 will also get successfully terminated and there will be no deadlock in the system. So you can clearly say in this diagram, in this RAG, there is no deadlock. So what is the learning? What is the learning in this diagram? Whether there is a circular weight? Yes. See, there is a cycle. There is a cycle in the graph. So if there is a cycle in the graph, then there will be always deadlock? No. It is only in the case of single instance. Means if the system is single instance and there is a circular weight. If the system is single instance and there is a circular weight, there will be a deadlock. Yes, it is true. It is true. In all the cases it will be true. But here the system is multi-instance. I am having two instances of R2. So if the system is multi-instance and there is a circular weight. Circular weight है? हाँ. इस diagram में I am having the circular weight. So can I say there will be a deadlock always? There will be a deadlock always? No. There will be not always deadlock. It can be possible, it cannot be, but we cannot say कि if the multi-instance system is there and there is a circular weight, there will always be deadlock. This is false. This condition is false. For always this is false because it is example. There is a circular weight, but whether there is a deadlock? No, there is no deadlock. But why? Because it is multi-instance system. So just remember this. मल्टी-इंस्टांस के केस में एंड सिंगल इंस्टांस के केस में दिस इज वेरी इंपॉर्टेंट. नाउ लेट्स सॉल्व द सेकंड क्वेश्चन. Let's solve the second question. The question is already asked in the GATE exam, so it is little complex. So if the question is like this, it will be very difficult to analyze it manually. That's why we are following this particular method, because the system, the diagram is looking very complex. So you cannot do it manually. Either you can, if you have practice of that solving, then you can do it manually, but I will suggest to follow this method because we are having sufficient time to solve the question in the GATE exam. It is not like a banking system in which we have to do the more and more question in less time. We are having sufficient time because every single mark is very important. So यहाँ पे you just follow this method, it will be very advantageous. So how many processes? Just write down the processes first. Again it is a multiple instance first of all, because R3, 2 instance of R3, 2 instance of R1, 3 instance of R2. Even if 2, we can call it multi. Here all the resources are of multi-instance. So let's say P0 P1, P2, P3. 4 processes are there: P0, P1, P2 and P3. Allocation and request. Allocation and request. What are the resources? R1, R2, R3. R1, R2, R3. Just write in the request also R1, R2, R3. First of all, fill the entries 0, 1, P0. Check the P0. P0 is having R1. P1, P0 is already holding the one resource of R1. So you can write 1 in this case because P0 is having one resource of R1. Check whether P0 is having any other. Yes, P0 is also having one resource of R3. So just write 1. So you have to fill this table first. P0 is having one resource of R1. P0 is having one resource of R3. Check P0 is having any other resource. P0 is not having any other resource. Check for P1. So just write 0 for the R2. For R2 it is 0. Check for the P1. P1 is holding one resource of R1. P1 is holding one resource of R1 and P1 is holding one resource of R2. See, P1 is holding one resource of R2. This big line R2. Check for R3 whether P1 is not holding R3, so just write 0. Check for P2. P2 is holding how many resources? So P2 is holding one resource of R2. Any other resource? No. Check for P3. So just write 0. P3. P3 is holding any resource? Yes, P3 is holding one resource of R2. Yes, P3 is holding only one resource of R2. Any other resource? No. So just write 0. Yes. Now check for the request. You have to do it very carefully because if there is any problem in this, it will affect the your answer. So do it with the proper. Do it with the careful. So request P0. P0 is requesting for R3, one resource of R3. P0 is requesting for one resource of R3 and P0 is requesting for one resource of R2 also. P0 is requesting for one resource of R3, one resource of R2. It is not requesting of R1, so just write 0. P1 is requesting, see, P1 is requesting one resource of this line, R1. P1 is requesting any other resource? No. So just write 0 for that. Check for the P2. P2 is requesting one resource of R3. Any other resource? No. Check for the P3. P3 is requesting two resources of R2. See, two lines. It can happen, our process can request for more than one resources. Yes, that is also possible. So two resources of R2. Two resources of R2 and any other, it is holding this one. It is also requesting for one resource of R1 and R3, no. So this is, you have to design the table first. Now check the current availability. What is the current availability? check for R1, R2, R3. R1, do we have any available? No, all the 2 instances are already booked, so just write 0. Do we have any availability of R2? No. See, all the dots are occupied. Yes, I am having one availability of R3. One availability of R3. Now this is my current availability. Now taking this current availability in your hand, check, can I fulfill the request of any of the process? See, P0 011, no, because I am having 001, but it needs one resource of R2, but I am not having, so I cannot fulfill. 100 for P1, no, P1 needs one resource of R1. Do I have one resource of R1? No. P2 001, P2 needs one resource of R3. Do I have? Yes, I have one resource of R3. So what I will do, I will give this one resource to the P3 first. So P2 को ये वाला एक resource दे दिया. Just remove this. This one resource will be given to the P2. P2 will get terminated. P2 will get terminated successfully. When P2 will get terminated, whatever the resource it is occupying, it is holding, it will be released. So when it will be released, I will add it. If it is released, my current availability will be updated. So 010 will be added. 0 plus 0 0, 0 plus 1 1, 1 plus 0 1. So this is the current availability, new current availability. Now check 011. Can I fulfill the request of P3? No, because P3 needs 2 of R2. I am having only 1. So check again from the P0. 011. Do I have 011? Yes, I can fulfill the request of P0 because P0 needs 1 of R2, 1 of R3, and I have 1 of R2 and R3. So I will fulfill the request of P0. When I give these resources to the P0, P0 will successfully terminate and it will be removed from the system. जब ये remove हो गया, so whatever the resources it is occupying, that is 101. 101 I will add, simply add, so it will be 1 1 2. So this is my current availability. I am just writing here 112. R1, R2, R3. So this will be the current availability, which is a new availability, updated availability 112. And I am having now 2 processes left. Can I fulfill the request of P3 still? No, but no problem. P3 can wait. But can I fulfill the P1? Yes. P1 needs only 1 of R1. I am having 1 of R1. I will simply give to the P1. So P1 will get terminated. So it will be removed from the system and whatever the resources it is allocating, it will be freed. So जब ये free हो गए, so I will simply add, so 2 2 2. So this is my current availability, that is 2 2 2. So what is the last P3? P3 needs 1 of R1, 2 of R2. I am having enough. I am having 2 of R1, I will give 1. I am having 2 of R2, I will give 2, both. So P3 will also get successfully terminated and it will be removed from the system. So whatever the resource is 0 1 0, it will be again added. So this will be the current availability. This is just for a knowledge, like what is the current availability if they ask at the last. So you can say 2 3 2. And the main question is it covered? 2 3 2. So this is the, if they ask what is the last availability, updated availability, so you can say 2 3 2. But mainly they will ask the question whether this contains the deadlock or not. So you can clearly say no, there is no deadlock in the system because first of all P2 will get terminated. You can also write the sequence explicitly. Sometimes they ask the sequence also. तो इसमें सबसे पहले P2 execute हुआ, P2 के बाद P0 execute हुआ था, P0 के बाद P1 execute हुआ था, फिर P3. So you can write the sequence also in a rough page so that if they ask for the sequence, you can write the sequence also. But the main point is कि whether this system contains a deadlock, no. So you just need to clear one thing, that is कि by using this method you can easily say if there is a very complex RAG or they are asking for the deadlock occurrence or not, so you can use this method. This will make the question very easy. And the second one is the theory part, that is if the RAG is having multiple instance and it contains a cycle, whether there will be a deadlock always? No. If there is a single instance, then there will be a deadlock always if there is a circular weight. But here in the multiple instance, if there is a circular weight, then there will be always deadlock? No. This is false. MI means multiple instance, circular weight, there will be always deadlock? No. This is false. This is true for the single instance, but it is false for the, it can be, it cannot be. Means it is not the, it is only the sufficient condition, it is not the necessary conditions. But in single instance it is the sufficient and necessary condition for the deadlock. But for multiple instance it is the sufficient condition but not the necessary. So if there is a circular weight in the system, but in the multiple instance you can't simply write it, there is a deadlock. Because we have seen the previous example जिसमें circular weight था but there is no deadlock in the system. So this is how we have to solve the question in the RAG, whether the system contains the deadlock or not. So अगर आपको वीडियो पसंद आए तो प्लीज़ इसको लाइक करना, शेयर करना एंड प्लीज़ सब्सक्राइब माय चैनल. थैंक यू.